The evolution of large language models mapping the AI revolution. The Genesis, 2019 to 2021, the Foundation era. The LLM evolution timeline begins with a handful of pioneering models that would fundamentally reshape artificial intelligence. In the 2019 to 2021 period, we see the foundational blocks being laid with models like GPT-1, T5, Codex, and Anthropic's early experiments. This era represents the proof of concept phase, where researchers demonstrated that transformer architectures could be scaled to achieve remarkable language understanding capabilities. GPT-1, though modest by today's standards, proved that unsupervised pre-training on vast text corpora could create models with surprising linguistic competence. The introduction of T5, or text-to-text transfer transformer, by Google established the paradigm of treating all NLP tasks as text generation problems, a concept that would become central to modern LLM design. Meanwhile, Codex showed that language models could be specialized for code generation, opening entirely new application domains. The acceleration, 2021 to 2022, the scaling revolution. The 2021-2022 period marks the great acceleration, where the industry learned that scaling laws weren't just theoretical, they were practical roadmaps to capability improvements. This era exploded with diversity and specialization. The model zoo emerged. InstructGPT introduced the crucial concept of instruction following, showing that models could be fine-tuned to better understand and execute human requests. WebGPT demonstrated that LLMs could be enhanced with web search capabilities, presaging today's AI search revolution. ErnieBot, Titan, Hyperclova, and other international efforts showed that LLM development was becoming a global phenomenon, with different regions developing models tailored to their languages and cultural contexts. Specialization began. CodeGen, GLAM, and MTNLG represented early specialization efforts, models designed for specific tasks like code generation or multilingual understanding. This period established that general capability and task-specific optimization could coexist. The breakthrough, 2022, the ChatGPT moment. 2022 stands out as the watershed year when LLMs transitioned from research curiosities to mainstream phenomena. The release of ChatGPT in late 2022 created the iPhone moment for artificial intelligence, demonstrating to millions of users that AI could engage in natural, helpful conversations. The capability explosion. This year saw an unprecedented diversity of models emerge. OPT, Bloom, Palm, Chinchilla, GPT-4, Claude, Lambda, AlphaCode, and many others. Each model pushed different boundaries. Palm with scale, Chinchilla with training efficiency, AlphaCode with programming capability. The emergence of Sparrow and constitutional AI research showed the industry grappling with alignment and safety concerns, recognizing that powerful models needed to be both capable and controllable. Open source versus closed development. Bloom and Opt represented significant open source efforts, while GPT-4 remained proprietary, establishing the tension between open and closed development that continues to define the field. The diversification, 2023, the application era. 2023 marked the transition from pure research to practical application, with an explosion of specialized models and commercial implementations. The coding revolution. StarCoder, CodeGen 2, Code T5+, and Replit Code V1 showed that code generation was becoming a solved problem for many use cases. The integration of AI into development workflows accelerated dramatically. Multimodal integration. GPT-4's multimodal capabilities, combined with specialized vision language models, demonstrated that the future of AI wasn't just text, it was multimedia understanding and generation. Efficiency and accessibility. Models like Vicuna, Falcon, Moss, and ChatGLM prove that high-quality language models could be developed and deployed more efficiently, democratizing access to advanced AI capabilities. The consolidation, 2024, the platform era. 2024 represents a maturing industry where the focus shifts from pure capability demonstration to reliable, scalable platforms. The big players solidify. GPT-4, Claude 3, Gemini 2, and Llama 2 represent the consolidation around a few major model families that have achieved both high capability and operational reliability. Specialization deepens. Models like DeepSeek V2, DeepSeek V3, Qwen 2, Mistral, and Yi Large show continued specialization for different use cases, languages, and deployment scenarios. The infrastructure layer. The evolution shows the emergence of an infrastructure layer, with models optimized for different deployment constraints, from edge devices to data centers, from real-time applications to batch processing. Key evolution patterns. What the timeline reveals. 1. The scaling paradox. The timeline shows that while model size generally increased, efficiency improvements often mattered more than raw scale. Chinchilla's success with optimal compute allocation influenced an entire generation of right-sized models. 2. The specialization imperative. The evolution from general-purpose models to task-specific variants reflects the industry's realization that one-size-fits-all approaches have limitations. Code models, conversation models, and reasoning models each require different architectural and training optimizations. 3. The open-closed tension. The timeline reveals an ongoing tension between open-source efforts like Bloom, Llama, and Falcon, and closed commercial models like GPT-4, Claude, and Gemini. This tension drives innovation in both directions. Open models push accessibility, while closed models push capability frontiers. 4. The multimodal convergence. The progression toward multimodal capabilities isn't just additive, it's transformative. Models that can reason across text, images, code, and other modalities represent qualitatively different AI systems. 5. The geographic distribution. The timeline shows LLM development becoming truly global, with significant contributions from the US, OpenAI, Anthropic, and Google, China, Baidu, and Alibaba, South Korea, Naver, and other regions. This geographic diversity enriches the field and ensures multiple approaches to AI development. The acceleration phenomenon. Why evolution sped up? Compute infrastructure maturity. The evolution accelerated as cloud computing infrastructure became capable of supporting massive model training and inference at scale. What took months in 2019 could be accomplished in weeks by 2023. Knowledge transfer. Each breakthrough enabled faster subsequent development. The transformer architecture, established training practices, and evaluation benchmarks created a foundation that new teams could build upon rapidly. Competition and investment. The commercial success of ChatGPT triggered massive investment across the industry, accelerating development timelines and attracting top talent to LLM development. Open research culture. Despite some proprietary developments, the field maintained a culture of research sharing that enabled rapid collective progress. Looking forward, what the evolution suggests. Capability plateaus and breakthroughs. The timeline suggests that LLM evolution occurs in waves, periods of incremental improvement punctuated by breakthrough moments that redefine what's possible. The efficiency imperative. As capabilities mature, the focus increasingly shifts to efficiency, making models smaller, faster, and cheaper while maintaining performance. The application layer explosion. With foundational capabilities established, the next phase focuses on application-specific optimizations and integrations. The safety and alignment challenge. As models become more capable, the timeline shows increasing attention to safety, alignment, and responsible deployment practices. The broader implications beyond technical evolution. Democratization of AI. The evolution from exclusive research models to widely accessible tools represents one of the fastest technology democratizations in history. Economic transformation. The timeline maps not just technical progress, but economic disruption across industries, from customer service to software development to creative industries. Educational and social impact. The rapid evolution of LLMs is reshaping education, changing how we think about human-AI collaboration, and raising fundamental questions about the nature of intelligence and creativity. The meta lesson, evolution as strategy. Perhaps the most important insight from this evolution timeline is that successful AI development requires embracing continuous evolution rather than seeking perfect solutions. The organizations and researchers who have thrived are those who iterate rapidly rather than pursuing perfection, specialize strategically while maintaining general capability, balance openness and proprietary development to maximize both innovation and commercial liability, invest in infrastructure that enables rapid experimentation and deployment, and prepare for discontinuous breakthroughs that can reshape the entire landscape. The bottom line, we're still at the beginning. This evolution timeline, spanning just 5 years, represents one of the most rapid technological progressions in human history. Yet the trajectory suggests we're still in the early phases of what LLMs will ultimately become. The models of 2024 will likely seem as primitive to future observers as GPT-1 seems to us today. The evolution continues, accelerating towards capabilities we can barely imagine, built on the foundation of the remarkable progress mapped in this timeline. In the world of LLMs, evolution isn't just happening, it's the only constant we can count on.